Hello, we are doing a solution for Physics 240, exam number 2, during the winter 2013 term, and we're going to be doing question 13. So, question 13 is a capacitor problem. The upper capacitor with charge Q equals 180 microcoulombs on this plate is moved down to make connection with the two uncharged identical capacitors as shown below. What is the charge on the upper capacitor after the connection is made? So there's a couple key points to tackle this problem. First, we need to look at whatever formulas we need. So the two formulas we have are C equals QV and C series equals the sum of the inverses of the capacitance, all inverse. So that sounds complicated, but that's really just what we've been doing with capacitors in series all along, just in a fancy formula. So the first thing we're going to do is calculate what the net capacitance of that bottom branch is. Now, since there are two capacitors in series and they both have a capacitance of C, you just add up their inverses, first by just doing 1 over C plus 1 over C. You find what that is. Since they have a common denominator, it's already easy. So then you have 2 over C, and then the negative 1 is essentially just flip it and find the reciprocal. So now we know that the capacitance of the bottom branch is C over 2. The next part is the start of our system of equations. So this problem is going to end up with a system of equations. Since the top capacitor is attached in parallel to the bottom capacitor, now when I say bottom capacitor, I mean we're treating that whole bottom branch as just one capacitor with a net capacitance of C over 2. Even though it's really two capacitors, when we combine the capacitance like that, we can consider it one. So since they're both in parallel, they must have the same voltage across them. So this gives us the formula Q over C equals Q bottom over C bottom. So the capacitance on the top is just C, the capacitance on the bottom, as we found in the last slide, was C over 2. So now we do some algebra to eventually get the formula Q on bottom equals Q over top, Q on top over 2. So that's our first formula, and we found an equivalence between the Q top and Q bottom. The next part of our formula is we're going to be using conservation of charge, and since it's a closed circuit, the charge has to be conserved. So whatever the Q on the top capacitor is plus the Q on the bottom capacitor, they have to add up to whatever was initially in the whole system. So initially we had 180 microcoulombs, so whatever the top and bottom have, they have to add up to that. So now we can write our system of equations. So we have our two equations, 180 microcoulombs equals Q top plus Q bottom, and Q bottom equals Q top over 2. So using the first equation, we could sub in for Q bottom what we found in the second one. So we get 180 microcoulombs equals Q of top plus Q top over 2, which we got from the second equation. So now combining these, we get 180 microcoulombs equals 3Q top over 2, and this gives us with the final Q top of 120 microcoulombs. So we solve for the question, that would be D, 120 microcoulombs. Now, you could have, in the past equation, decided to solve for Q bottom and then sub it back into the other equation. It would have worked perfectly the same, and it would have been the same answer. Thank you.